Okay, so we have here an introduction to functions, or a review of functions if you've already learned this topic before. And so let's begin with a definition, okay, of a function. And what a function is, it's a rule or a machine with inputs and outputs. Something that goes into the machine, that's an input, and then something comes out of the machine, that's the output. And the key thing about a function is that for every single input, there can only be an exactly one output. Okay, so it can't have more than one output, it can't have less than one output. And so let's look at some examples of other functions here. You have a toaster function that inputs and outputs. The input is bread, it does some work, it outputs toast. A washing machine function that inputs dirty clothes, does its work, and then outputs clean clothes. So let's look at a math function now. You have this function f of x equals 4x. If you input x equals 5, and notice here what we're doing here, this is the work that the machine is doing. It's just literally replacing the x with the 5. Okay, and whatever result or answer of that mathematical expression, that's the output. And in this case, it's 4 times 5, so you get 20. See one more. We have x equals 7. The machine does its work, and it gives you 28. Okay. Now let's look at a birthday function. And the example of birthday is really going to help us illustrate what makes something a function or something not a function. So let's say we put in a name, in this case Mary Jo, and then it gives us an output, March 19th. Okay. We'll do a couple more. Kristen gives us July 26th. Serena, 10th. Kirsten, July 9th. Okay. And let's say I did this for the entire class, and I have an entire list of inputs here, which are all of the names, and then a list of all the outputs here, which are all of the birthdays. And if you notice, every single person has exactly one birthday, or another way to put it in function terms is that each input has exactly one output. Everybody's got to have one birthday, and nobody can have two birthdays. Now, there's an interesting case here that sometimes different inputs may have the same output. So let me say this one more time. Different inputs can have the same output. And so we actually have a great example in our class. We have Louisa, who's born on November 5th. So the input is Louisa, the output is November 5th. Okay? And then we also have Jennifer, who's born on November 5th as well. The input is Jennifer, the output is November 5th. So it's okay for two different inputs to have the same output. That's like two different people having the same birthday. But it's not okay for the same input to have two different outputs. That's like saying one person has two different birthdays. Okay. And so let's look at an example here that is not a function. It's called a relation, but it's not a function. F of x equals x plus or minus 3. We are putting in 2 as the input, and the function has to do two computations, 2 plus 3, which gives us 5, and 2 minus 3, which gives us negative 1. So in this case, we only have one input, 2, and the number 2, and we have two distinct outputs, 5 and negative 1. And so this is not a function. This is like saying one person has two birthdays. And when we're talking about function testing, we can actually do this graphically using what's called the vertical line test. And this is the rule. If no vertical line intersects the graph at more than one point, then the relation is a function. That means if you run a vertical line through the graph, it shouldn't intersect the graph more than once, okay, at the same time. Otherwise, it's not a function. And so let's illustrate this with a couple of examples here. Here I have a relation. Maybe it's a function, maybe it's not. And these are all the inputs. I input 1, I get 1, 2, 2, 3, 2, 4, 5. Okay, and I plotted all of these points. I plotted all of the inputs on the x-axis, all of the output on the y-axis. And I have my vertical line here. And if this vertical line can run through this function, but never intersecting more than one point at the same time, then it is a function. Okay, so let's test it. It runs through, comes back, and if you notice in that sequence, it went a little bit fast, but the line never touched 2 points at the same time. Okay, so in this case, yes, it is a function. Okay, let's look at another case here. Is this a function? And we'll take these points. We're going to run our vertical line test. So the line runs through, and it actually found something right there. Okay, these 2 points, 1, 1, and 1, 0, 5. The line touches both of those at the same time, and you can see this is the same input. I wrote it twice on 2 different lines, but it's the same input, and it's giving me 2 different outputs, 1 and 0.5. So no, this is not a function. Okay, and so those were examples of just specific points. Let's look at actual equations now. I have a relation here. F of x equals 0.1 times x to the third plus 0.25 x squared plus 2. And I'm going to take my vertical line and run it through. And if you notice, it touches the graph, but it never touches it in multiple points at the same time. I'll play it back a little and slow it down if you need to see it again, but it only touches the graph at one point at a time. So yes, this is a function. Let's look at one more mathematical relation. Quantity x minus 2 squared plus quantity y plus 3 squared equals 25. And for those of you who are familiar with this equation, this is just a circle with a center at 2, -3, and a radius of 5. And if I run this vertical line through, you can see already it's running through multiple points. There we go. And it's got, if you can see here and here, is where the 2 intersection points occur. There and here as well. So there's multiple places here where the vertical line touches the graph at 2 points at the same time. And so it fails the vertical line test, and that means it's not a function. And so there you have it, the basic fundamentals of a function. Just keep in mind that it's an input-output machine, but every input has got to have exactly one output.